Awesome. So yeah, so like Sergeant was just saying, my name is Dylan Palmieri, and I'm going to be talking to you all a little bit about Git today. Um, we're going to start off with a little bit of sort of theory, some history, fun things like that, background info, and then we're going to move into a demo section. And while we're doing any of this, I've got the chat open here, so if anyone has a question, feel free to just drop it in there, and will hopefully see that shortly and can answer your question. So what is Git and why do you care about it? So Git is a distributed version control system. So sort of breaking that down a little bit, a version control system is a system which keeps versions of files. So if you haven't used Git before, if you've used Microsoft Word or Google Docs, the version tracking system that they have is a perfect example of a version control system. It allows you to move between points in the history edits of the different files that you have that are being tracked by this system. Git is a distributed system, so instead of having to check in your files to a server, all of the copies of the repositories that exist at any point in time are all equally as valid as any other. So instead of having to wait a long time to get your code checked into a server somewhere, with Git, you can push it to a remote, and whether that is something on GitHub, something that you're running locally, all copies are equally valid. And then one of the really cool things that Git does, the way that it actually tracks your files, is using a snapshot model. So other version control systems, many version control systems, which you may have used in the past, like for example Google Docs and things like that I was just talking about, will use uh, a patch model where instead of continuing to track files over time, they track the changes in the files, which makes a lot of sense until you kind of want to start exploring and manipulating these differences in different ways, which is where Git's snapshot model really comes in handy. So what Git does that's really interesting is it creates these full kind of sets of files. So like you can see here, version 1, we check in these files. Version 2, we make changes in file A and file C, but we haven't made any changes in file B. So that is, if you're familiar with Linux systems, you can consider that like a symbolic link to file B. So we're saying nothing has changed, but we want to continue to include file B. So we're going to include a link back to the original and reference that link. Really interesting, and we're going to talk about that a little bit more once we get into branching and fun topics like that. But that's sort of the foundation of Git right there. Brief history of Git. It was developed in 2005 as a response to a change in licensing for a product called BitKeeper, which you may be surprised to learn is now defunct. This was used by the Linux kernel. Was one of a major user of that in between, I believe it was 1995 to 2005, and then from what I understand, they wanted to start charging for their service, and the Linux kernel and open source organization didn't appreciate that very much, so they decided to build their own, and they were very successful. Git has pretty much above and beyond, I think, overrun every other version control system that there is. Basically, people talk about other systems like Mercurial, Subversion occasionally, but I have never seen a good use case for either of those that could not be equally solved by Git. Yeah, and so the primary initial author, Linus Torvalds, famously, primary maintainer for the Linux kernel. And these are kind of some of the principles that Git was designed around. So speed and simple design, strong support for non-linear development, and that's where we get kind of into that distributed model once again, being fully distributed, able to handle large projects efficiently. So Git in theory. So this is sort of a couple of these principles, these really interesting features of Git. The first is integrity through hashing. So hashing is a process through which you can take a file or group of files, or realistically any portion of memory on a computer, and you create a unique identifier for that section of memory. And every time that you make a commit in Git, Git creates a hash, or a checksum is another word, that is uniquely associated with that change. So one of the really cool things about that is that every time you create a change in a file, it creates a new hash. Once that change or set of changes, I guess I should say, has been committed to your repository. Another really great thing about Git is that it makes it very difficult to delete anything. So if you delete a file, that is saved as another version in your repository. So you're not actually deleting a file, you're creating a new commit wherein that file is deleted, which is a little bit of a subtle distinction. But basically, that means that at any time, you can roll back that commit where you deleted the file, and that file is just magically there again, and it's its most recent version. There are ways that you can sort of edit your Git history, and you can actually delete things out of your Git history. But Git by design makes that pretty complicated. And it's not something that you want to do often, especially if you are collaborating with people, as it can lead to some unintended consequences there. So there are kind of three different parts of your Git workflow, right? That you should sort of conceptualize while you're doing this. And once again, I'm going to talk about all these things more when we get into the demo section here in a little bit. But the first part of any Git repository is sort of the working directory, your working area. So you'll have files that have been modified, files that have been unmodified, and then you can choose to move those into the staging area where you're going to create these commits. You're going to design whatever, files, portions of files you want to be included into these commits. And then you're going to bundle all of that together into one commit object and add that to the repository. And then that's going to become part of your canonical code. Or I should say, not even necessarily code, your canonical set of files in the repository. And then the last topic here is branching. And this is an incredibly powerful feature. This is where a lot of the sort of the magic of Git happens. And you could certainly give an entire presentation on just branching, and take the whole time slot that we have here today. So I'm going to try to limit myself a little bit and not do that. But it is really interesting, and sort of the different philosophies around branching and how you manage branches. Something that's called Git flow, which also going to talk about a little bit later. Can be really interesting to sort of take a dive on and learn some more about that. Cool. So now we're moving on to the practical portion of this. So let's see. Oh no, I forgot to start my server. So I'm going to start my server here, and then we're going to talk about these topics. So we're going to start with commits and sort of move through this list. I guess while we're starting the server, if anybody who has access to Open Science Lab right now would like to join me and go along with this. Um, more practice is always better. There will be a couple things that I'm going to do that you won't necessarily be able to follow along 100% with. Um, but things like solving a merge conflict are always good skills to have in your toolbox, especially when you're working with groups of more than one person. All right, so let me make this a little bit bigger. So that's perfect. So I'm going to be doing most of the work here in a terminal, just because that's where I feel comfortable. But I'll also, once we sort of get into it briefly a little bit, I'll show off this nice little um, Git extension here that is available in Open Science Lab, of course. And I was going to say I believe it comes as default with most Jupyter hubs, although I'm not sure if that's the case. But if you are using a different Jupyter hub, you can certainly request that the admins there and install that for you in your image. It's very straightforward. So the first thing that we're going to do here is we're going to make a repository. So we're going to make a new repository and cd into that. This is very exciting. And then, so we can see there's nothing in here, totally empty. So the way that we tell Git that this is a new repository is with git init. So you can see it gives this little message here. You might see this also. So Git has, I guess recently is not necessarily accurate, but Git has moved to calling all of the first branch that is created the main branch, and that's what this little warning is about. We can just keep working off of this master branch for right now, but you'll see it gives you this nice little message right here where it's telling you if you want to change the name of this branch, this is how you do that. So we have this repository now. So the first thing that we need to do is we need to add things to our repository. So let's see. How's that? Is that a little bit easier to read? Maybe. Yeah. So the first thing that we need to do is add something to our repository, right? So I'm going to do right now is we're going to go in here and we're going to see that I've cloned in the Jupyter book for our workshop, which is something that we're all going to do together here in a little bit. And I'm going to grab the notebook and the environment out of that workshop. So this might actually be easier to do. This. We're going to grab this, and then we're going to move this into our new repository. We've got this new file checked in here, which is very exciting. And then we're going to grab this notebook also, which is what the environment is for. Move that into our new repository. Awesome. So now if I go back to our new repository, we can see that there are two new files here, which is great. So now the most important command that you can possibly run, git status. And you can see here, it tells you what branch you're on. It says we haven't committed any branches yet. And these are the untracked files that are in our repository that we could potentially add. So you can see it gives this nice little message here. Use git add to include all that we committed. So that's what we're going to do. So we'll add the wetlands notebook and the associated environment to the repository. And then if we use git status again, this is once again kind of calling back to the 3 stages that I had mentioned before. This is a perfect example of that. So we have this directory, which is untracked. We have these 2 files, which are now in the staging area. And you can see here, we get this nice little message about how to unstage them. And then we haven't added anything to the repository yet. So now I want to add these to the repository, right? So I can do that. Git commit. And then it's going to drop me into an editor. Vim is by the default the editor that you'll get on a lot of systems. Other options sometimes are Nano, but Vim is one of the more feared, I think, editors because it's very opaque at first if you don't know what you're doing. So in Vim, I'm going to press I to go into insert mode, and then I'm going to put in my commit message. So I'm going to say this is a feature. Then this is the initial commit. And then on this second line here, I'm also going to say notebook and environment. Now, very important, most important thing, if you're ever going to do anything with Vim, how do we quit? :WQ. So W is for writing, Q is for quitting. And then that's going to exit Vim. So you can see we had a commit, and then this is the output from our commit. So this is the root commit. This is that hash that I was talking about before. So this is the unique identifier for this commit. And then this is our commit message here. You can see it does squash it into 1 line, but it is in fact 2. And then it tells us what changed. So if we want to look at this again, we can use this command git log. And we can see here that in our repository, we have 1 single commit, and we're adding the notebook and the environment. This is the hash of that commit. Right now, this is telling us that the place that we are looking, the branch that we are looking at, our current head, is at the end of the master branch. Obviously, I was the author of this. This is the date, and this was the message. Let's see. Yes. So the sort of interesting thing here is that as you add new commits, what you're going to actually end up doing is you're going to end up forming this tree of commits, right? So what we've just done here is we've created, you can see it literally says this is the root commit, right? This is the first commit in the repository. This is the root of our commit tree. And you can see sort of the branches metaphor kind of naturally follows that, right? We're going to have branches off of potentially the root, potentially a little bit later, and it can be a little complicated, but this is sort of the jumping off point for all things Git and interesting. So we have a repository. It's local on our computer. I guess maybe local would be a more accurate air quote there. But keeping things just in one place is not necessarily the greatest idea, right? If, I have a Git repository, it's on my laptop, the motherboard goes out, or, the battery overheats and it melts something important, right? And my hard drive is gone. I can't do anything about it. My repository is gone. Fortunately, there are services that you can use that will allow you to save your repositories on their servers effectively for free. I'm going to be talking about GitHub here because that's what I use a lot. I'll talk a little bit about GitLab and other things like that a little bit later. But what we're going to do here, actually, maybe I should zoom in on this a little bit. So what we're going to do here is we're going to create a new repository. So this is the ASM Open Scilab organization. This is where we're going to be hosting this repository. So I've already signed into my GitHub profile right here. And because I am an owner of this organization, I can make new repositories in this organization. You can also do this for your personal GitHub. We're going to talk about that a little bit later as well when we talk about forking repositories. But right now, I'm just going to create a new repository. So we are going to call this Wetlands Notebook. We're going to add a description that tells people about what this repository is. This is going to be October 2024. So we want to make sure that this repository is public. So anyone on the internet can see this repository. And then anyone can clone it as they like. This doesn't necessarily mean that anybody can contribute to it. Once again, we're going to talk about that a little bit later when we talk about forking. But when you're making a repository that you want to share, public is the easiest way to do that. So now we're going to create our repository. And this is not necessarily the most intuitive thing. You can see that there are some instructions here, which is really nice. So this is once again from a terminal, just like we're going to be doing. So if you don't have a repository already, this walks you through creating a repository. If you do have a repository like we do, these are the commands that we're going to use. So moving back to our repository here, the thing that you want to do that you want to make sure is you want to copy this link. So another important thing that I should talk about while we're doing this is you can see that this is not the HTTPS link. This is the SSH link. And a couple years ago now, GitHub, I should say, moved away almost entirely from allowing you to authenticate over HTTPS. So now you need to set up your SSH keys in order to do that. So that's also pretty straightforward once you've done it a couple of times, but the first time that you do it, it can be a little complicated. So I've already set up my SSH keys on this because I didn't want to go through doing that live. But GitHub has some really nice documentation on that, but effectively all you need to do is generate a key, and then you, with this SSH keygen command, and then you tell it what kind of key you want, and then you sign that key also. And I think if we go back up far enough here, we can look at what I did yesterday. And we can see this is literally the command that I ran yesterday. So SSH keygen, this is the type, the algorithm that they're going to use to generate the key. And then this is the person that's signing the key, right? Me. And so you run this command, you get a couple files. You'll get a private key and a public key. and then you add your public key to your GitHub profile. So we go back to this, I can show you me. So under my profile here, you can see there's this little SSH and GPG keys. So these are the SSH keys that I have. So this is the one that I am using actively. This is the one that I have on my my laptop. And then we could also talk about GPG keys also. So GPG, these keys are a way of authenticating your identity in Git. It's kind of a further authentication step. So you check in these GPG keys, and then you sign each commit with that key. So if you are moving, if you have a couple different laptops or something, you can use potentially the same set of SSH keys to use Git, but you can have different GPG keys. And as long as you've checked those both in to your profile on your two laptops, Git will verify both of those as being signed by you. So for example, if we go to a repository that I have committed to, let's see, why can't I? So let's see, let's just go to this repository. Oh, look, and this is perfect. So you can see, so Alex has set up his GPG keys because we've got this little verified button right here. So this is really nice. So you can see that this commit was created. Oh, so this is really interesting. So this is actually, this is the github.com signature. So this is not actually on a laptop. This was created using the GitHub built-in editor, which is why it's signed here. So GitHub can verify that it created this commit because it has its own signature, and it was the one that did that. Okay, circling back around, we're going to add this. So we've created this repository. We checked in a couple of files. Now we want to add it to our remote. So what we're going to do is git about add. We're going to call this origin, is sort of the canonical name for this. And then we're going to give the SSH URL, I think is the SSH link to the repository. So you can see this just worked. But if we go back to the repository, there's nothing there. And the reason that there isn't anything there is because we've added this as a remote. So you can see here we've added this origin, but we haven't pushed anything to it yet. So we're going to push to the origin remote our master branch. If we do this right now, unprotected private key file. So this is something that you're going to run into on OSL. And the reason that this is because of some permissions things that we do when the server starts, basically because of the way the image gets cloned in, all the files under it have to have a certain set of permissions. But what this is telling us right now is that these permissions are too open. So what we're going to do to fix this is we're going to go change the permissions on our keys. So right here, we're in our home directory, and we can see here that we've got this .ssh directory. And so this is where all of your SSH keys live. So if we cd into this directory, we've got these two keys. And if we scroll back up here a little bit, we can see this message gave us this URL here. And this is the location of this key. So this is, you've got this .pub key here, which is your public key. And then this key that's just sitting here by itself is the private key. So now we have to change the permissions on these keys. And unfortunately, this is the part where I have to go to Google because I can never remember what the proper numbers are.
600 should be good.
600. Thank you, Alex. So we're going to, let's see. This is the magic. This is the Linux magic right here. So this we're changing, so chmod right here, we're changing the mode of the file is kind of the way that you can think about this. And then they have this really interesting way, and by interesting I mean incredibly opaque, and I forget every time that it's been longer than a day since I've done this what these numbers actually mean. But we can run this, and then if we look at our files again, we can see that this is what they looked like before. This is what they look like now. So we've lost a bunch of permissions off of these. So if you're really interested, and I don't know, I think that this is kind of fun, you can look at manual page for this chmod command using man. And you can learn about the way that they use file permissions and stuff. But what we've done here is we've made it so that these two files, our SSH keys, are only readable and writable by our user. So nobody else can see them, nobody else can edit them, which makes a lot of sense. You don't want people stealing your identity just because they can look at the files on your computer, right? So now if we go back to our new repository, we can look at this here. We use git status again. We can see we're on the branch. We have these untracked files. We look at our log. We have this, but we haven't added it to our repository. So this is another nice thing that you can do with SSH keys is it is optional. You don't have to, but you can add a passphrase for your key. And that's just another layer of security on your commits, making sure that when you commit something, it is actually you that's adding to the repository. So you can see here, this is all of the output from our push here. And if we go back to our wetlands notebook repository now, we can see that there are a couple of things in here, which is really awesome. And if you click, this is really nice here. I really like the way that GitHub does this. You click this little thing, you can see additional descriptions down here. So this is the second line of our commit message that we added. And this repository now exists. So you could go on here, you could clone this repository. It's available to the public. And I think that we're going to be using this a little bit later also, which is really great. Let's see. So one of the last things that I wanted to talk about in this section is what makes repositories good. So this is really nice right here. You can see this big add a README message. Having a README in your repository, especially at the top level, is really nice. It helps people understand what your repository does. Potentially some of the things that maybe needed to run it. If you need to link to somewhere else. If you have, a description of the project that you're working on, it's linked on a web page somewhere. You can just link to that. But having some sort of message that tells people what your files are actually doing is really nice and really helpful, especially for people who are trying to or who discover your repository, who maybe have never seen it before, who don't understand the greater context of the project that you're working on, and potentially might want to contribute to it later at some point. Let's see. Spent perhaps a little bit longer than I should have, so we're going to go through the stuff a little bit more quickly. Um, So I guess the next thing, probably one of the most important things that I'm going to be talking about here is branching, and I kind of touched on this a little bit earlier, but this is the way that Git works with more than one person. So what I'm going to do here is I'm going to look at a list of all my branches here right now with this git branch -a command. So you can think of the A as all for list all of the branches. So you can see right here, I have the master branch, and then I also have the remote branch that it's tracking that is, people will say upstream of the master branch. So if this little asterisk here is denoting that I've checked out the master branch right now. So if I want to make a new branch, we're going to just say git branch, and then I'm going to give it a name, and this is going to be develop. So if I run git branch -a again, we can see we have a new develop branch, which has branched off of the master branch that we're currently in. So we're going to go look at that. We're going to say git checkout develop, and it gives us a little message that we've switched to the develop branch. So now that we're here, I'm going to open our wetlands notebook. I'm not actually going to run this, so I'm just going to select no kernel here, and then I'm going to add a little markdown cell right here. Maybe we'll just do this. Oh no, that's right. Give some people my unsolicited opinions about how great Git is. We're going to add this to the notebook. So moving back here, so we saved this. This notebook is now saved. And if we do, once again, the most important command, git status, you can see that here we've modified the wetlands notebook. So we're going to get a little, we're going to use some shortcuts here. So this is fun. So we're going to do -am here. So what we're doing here is this -a is going to commit all of the currently tracked modified files, and then this m allows us to specify a message in a string right here without having to go into it. So if I run this right now, I've created a new commit, which is really great. So now, I've used git push, but I didn't specify the branches. So this is really nice. It gives us this little message right here and tells us if you want to push, if you don't want to have to specify the branch every time that you push something, then you need to tell Git to set upstream the develop branch at the origin remote. So we're going to do that. And then we can look at this. And this is really nice. So Git has detected that we're using GitHub because that was the way that we set up this repository. And it's saying that we can create a pull request by visiting this link here. So we're actually going to go back here, and I don't even need to refresh the page, but we have a new branch here that's being tracked, and we get this little pop-up that says it had recent pushes 4 seconds ago. So I want to get my commit onto the main branch of the repository, right? So if I want to do that, the way that people are going to contribute things to your code is by making a pull request. So I'm going to make a pull request with my change. I'm going to give it a good title. And then I'm going to write a short description here. And then I'm going to say, I am the person that's working on this. I'm going to ask Alex to review it for me because I know he's really nice and he'll give it a good review. And then I'm going to say that this is an enhancement because it makes the repository fundamentally better. And then we're going to create a pull request. And so now if I'm working on this repository with other people, they now have the opportunity to see this pull request in this nice pull requests tab right here. And they can look at it and they can see somebody wants to make a change to the repository, and they can go over in this little nice window right here and they can review the changes and determine whether or not that's a change that should be pulled into the branch of the repository. Let's see. So I think those are some of the big things that I wanted to talk about. One sort of last note that I'll leave this with is a note about style in Git. So the convention is that Git messages are written in the imperative, and I didn't do that here because I was making my silly little commit. But if we go here, like for example, this commit that Alex made to the repository, to the the Open Starlab environments repository, deprecate Hydrostar environment YAMLs. You start with an imperative here, so we're starting with deprecate, right? To do something is the convention, making it easier to understand sort of what's going on here. So like this this commit that I made down here had tools for the EarthScope ICE course that we were running at this point. You can see that I have prepended this with this feat tag. And this is another stylistic thing, something that I like, that's called conventional commits. So there are a couple different, I guess, prefixes that you can put on your commits. Feat for a feature. Fix is another one that we use when you're making a minor fix that isn't something that would necessarily necessitate like a new version of a product. Or docs example for when you're working with documentation. So one of the sort of neat ways that you can use this is when you are creating pipelines around your code. So for example, I added this this commit to this repository, and what happens is every time that somebody commits to this repository, it updates an associated Docker image that this repository creates. And if you are updating the documentation for the repository, you shouldn't rebuild the image because nothing about the image has changed, right? So I added this nice little thing that says if your commit message starts with this docs prefix, don't rebuild the image, which has been really nice. And let's see, I think actually this is NISAR, which is what we named this. And so you can see here, there's actually an example of this running. So this repository uses the same workflow, and I had a commit that was prefixed with the docs tag, and it skipped this workflow for this because of the way that this commit was written. So sort of keeping that in mind, that's a little bit more of an advanced configuration. It takes a little bit more work to set those things up, but being thoughtful about your commit messages, especially when you're thinking about automation, and then also just making it easy for people to understand that aren't you, is always beneficial. I think there's a lot that you can learn from reading through the commit messages, especially when you're trying to fix a problem that you may not be familiar with at the outset. Right. So I think that is everything that I had to say. Oh no, I'm sorry. It's absolutely not everything I had to say. There is one more slide here, which is talking a little bit about remotes. And basically the moral of the story here is that there are several services that you can use as your remote hosts for your Git repositories. And they all are do a lot of the same things because they're all supporting Git, right? They're all supporting the same tool. It's just sort of different flavors the way that they approach it. So GitHub and GitLab are sort of the two big ones. There's a couple others, like Atlassian has, I believe it's called Bitbucket. AWS recently sunset their Git service, which was called Code Commit. But the two main services that you're going to run into are GitHub and GitLab. And sort of the big difference between two of those from a user perspective is that you're going to run into GitLab more often when you are working with potentially sensitive information, because GitLab is open source, which means that people can download the GitLab source and run an instance of GitLab themselves behind, potentially a firewall or a VPN, so you can host configurations or potentially other sensitive proprietary code without having any sort of potential of somebody accidentally clicking the make this repository public button and sharing those confidential secrets with the world. A couple of other sort of distinctions there. So GitLab is open source and self-funded also is kind of another point there. They make, I believe, most of their money off of their enterprise subscriptions. And GitHub is owned by Microsoft, so that's where they get all of their money. And a nice thing about GitLab is that it's not just a code hosting service. They also provide an integrated deployment platform, which can be really nice. So you don't have to use something like AWS. If you want to deploy code, you can use the GitLab deployment platform instead of having to use an alternative provider. Perfect. So there's also a list of resources here, a couple things that I put together. This the Git book is very nice. It's really well written. A lot of this presentation was developed off of the material from that, so I would highly recommend that you go check that out if you are new to Git. Um, if you want to get hands-on with some of the Git branching things, especially in sort of learning these different Git operations, I could not recommend this website enough. Learn Git branching. Um, this is the website that got recommended to me when I was in university learning how to use Git. Um, and I felt like it was really effective then. And I still go back to it now sometimes for some of their more advanced tutorials, just to remind myself of the cool and interesting things that Git can do.